You've probably heard that dark matter and dark energy make up like 95% of our universe, but we have no idea what they are. So, what if the solution isn't about finding some new exotic particle? What if it's about completely rethinking the nature of space itself? In this explainer, we're going to explore a pretty radical theory that does exactly that. For decades, we've been trying to explain some really strange cosmic behavior. Like galaxies spinning so fast they should fly apart. We invented these invisible forces to make the math work. But what if the problem isn't about some missing stuff? What if the problem is that our most fundamental understanding of space is just wrong? So, the ideas we're about to get into come from a framework called the Unified Postmodern Theory, or UPT, and it's all based on data from Chat Truth. Now, just to be super clear, our goal here is not to prove this thing right or wrong. We're simply here to walk through it, to understand how it proposes to solve these enormous cosmic mysteries. So, with that in mind, let's dive in. So how in the world does UPT just explain away dark matter and dark energy? Well, it starts by taking our common sense idea of empty space and just tossing it out the window. And this, right here, is where things start to get really wild. Okay, the first huge idea from UPT is this. Space is not an empty box that just holds the universe. No, instead, space is the universe. It's a continuous, tangible medium, what they call the vacuum, and it has its own rules and its own behaviors. So if space is this tangible thing, what's matter made of? UPT calls the fundamental building block a foundon. So I want you to imagine the vacuum is like a giant solid block of foam. A foundon isn't some separate little speck that's in the foam. It's a specific individual piece of the foam itself. And because every single piece of this foam is a foundon, the entire universe becomes this seamless, continuous medium with absolutely zero empty gaps. Every particle, every star, you, me, every galaxy, it's all just a collection of these foundon domains, all touching each other. Okay, so let's get this straight. We have our new rules. Space is a continuous medium, and it's made of these things called foundon domains. So with that foundation, how does UPT actually solve the mystery of dark matter? Well, the explanation according to UPT is almost shockingly simple. Dark matter isn't some new exotic particle from another dimension. It's just normal matter, clusters of these foundons that happen to not give off any light or radiation. They're dark for the most literal reason. We just can't see them. So if it's not some mysterious gravity pulling things together, what is it? UPT says the effect we observe is purely mechanical. Think about two balloons pressed up against each other. There's a real pressure right there at the boundary where they meet. UPT calls this traction. It's not some mystical force acting across empty space, but a direct, physical push and pull between these touching vacuum domains. This slide really breaks down the two ways these so-called dark clusters have an effect. You can think of vacuum intensity as being kind of like density. So first, a denser region of this vacuum foam will literally push on a less dense region right where they touch. But second, a change in one region can send a ripple, a wave of changing density out through the vacuum. And according to UPT, these ripples are what we perceive as forces, like gravity. All right, that's dark matter taken care of, at least in this model. But what about dark energy? The mysterious force that's supposedly stretching our universe apart faster and faster every second? How does UPT's model handle that one? UPT's answer here is maybe even more radical. Dark energy doesn't exist. It's not a thing. There's no extra force. Instead, the vacuum of space itself has a built-in fundamental tendency to expand. It's just what it does, naturally. And this leads to a huge prediction that just flies in the face of the standard model of cosmology. Right now, we think the universe's expansion is speeding up. But UPT predicts the exact opposite, that the universe is always expanding, sure, but the rate of that expansion is constantly slowing down. It'll never stop completely, but it's always decelerating. This is a major and, more importantly, a testable difference. And the theory goes even further. It claims that all of the fundamental forces are just different side effects of this single basic tendency of the vacuum to expand. And then there's this bombshell. The speed of light isn't constant. According to UPT, light actually travels at different speeds depending on the local density of the vacuum it's passing through. Now, if that's true, it could change basically everything about how we measure the universe.
Okay, this is all a fascinating thought experiment, right? But how could you possibly test a theory this wild? Well, UPT suggests that if we can measure the energy state of the vacuum itself, we can actually find direct evidence for its claims.
To even try to do that, we need to know what we're looking for. The theory gives us a way to describe the energy and the movement within this continuous vacuum, and it all boils down to density and pressure. Okay, now don't worry about the math here. Let's just focus on what these equations are telling us. The first one for energy is just a way to measure the total energy in a given patch of vacuum. It says the energy comes from two places. One, how dense the vacuum is, and two, how lumpy it is, how sharply that density changes from one spot to the next. The second equation for mu is even more important. It basically describes a kind of pressure, and nature always wants to even out this pressure. The movement of energy to do that is what UPT says is motion and force. And this gives us two concrete, real-world ways to test the theory. First, instead of looking for gravity, we could map the density of the vacuum across a galaxy. The theory predicts we'd find these dense clusters, the dark matter, exactly where current models say they should be. And second, we can test the speed of light. If it really does change based on vacuum density, then our measurement of the universe's expansion, the Hubble constant, should be slightly different depending on which direction we look in the sky. Finding that variation would be absolutely massive evidence for UPT. So, after all of that, what's the big picture here? What is the core takeaway from this whole unified postmodern theory? It completely reframes the entire mystery. It suggests that to solve the biggest puzzles of the cosmos, we don't need to add new, unknown particles or invent new energy fields. Instead, we just need to understand the fundamental properties of what's already here, the vacuum itself, in a completely new way. And this leaves us with a fascinating, kind of mind-bending final question. For centuries, we have been completely focused on the actors on the cosmic stage, the stars, the galaxies, the particles. But UPT suggests maybe we should have been studying the stage itself this whole time. If the very fabric of space is dynamic and active, what other great mysteries have we completely misunderstood?